Review for the final. Part 5. Okay, I've drawn what appears to be a Ferris wheel. I will allow you to suspend your disbelief. And here's a Ferris wheel with some people in it. Yay! They're so excited. So my question is, what is the work done? All right, taking a person from this point, we'll say to the lowest point, imagine that's the lowest point, and bringing that person all the way up to the highest point. If you are moving at constant velocity. This is a strange question. It's a very conceptual question. Essentially, I'm going to kind of explain it to you briefly. What you take away from it is what's most important. If you're moving at a constant velocity, of course, you know that's centripetal, centripetal velocity is moving around it, and this is your tangential. Okay, so this is actually your tangential velocity. I'll put VT. Okay, so your tangential velocity is going to be constant. That means that it's pulling you this way as you're going this way, and it's pulling you this way as it's going this way. Let me put it to in slightly easier terms. You know that your centripetal force is your net force. And you know that your centripetal force is the force, all right, that pulls inward. Imagine that that's a yo-yo. A yo-yo on a string. Okay, and as this yo-yo goes up and around the circle, okay, so I'm going to show my yo-yo going around the circle. It is constantly being pulled inward that way. So as it goes around the circle to here, it is still actually, the net force is pulling it inward. But as it's being pulled inward, what's very interesting is it has this velocity going boop, upward. And as it's being pulled inward, it has this velocity that goes completely and totally perpendicular to the force. Because the motion is perpendicular to the force, there's no work being done. What is work? Remember that work, briefly, is force times distance, but they have to be in the same direction. The force here is not in the same direction as the movement, therefore there is no work. That's my video for you.